Hello Algebra 1 students, welcome to our first video on factoring. This is the first of two parts of factoring, and we're going to cover x squared plus bx plus c trinomials and difference of squares binomials. So today we're going to listen to an iTunes radio station. It's just classical guitar. I know usually I put the fun stuff in there, but I want this to kind of be a little bit more low-key. So I'm trying not to make it too loud, too garish. So I forgot to write the section number in real quick, so I'm going to pause it and go find that. Hold on. Okay, so it's 5 and 7. The x squared plus bx plus c trinomials are in 5, and then the difference of squares are in 7. Now, I hate to say it, but the heat's going to come on again, so hopefully it happens while I have it paused. But let's jump in and get moving, and then maybe it won't be quite so garish when it starts. Okay, so factoring a trinomial of the form x squared plus bx plus c. So basically what's happening here is we're going backwards. Like I called this in a previous video, it's kind of Jeopardy math. And hopefully by the time you're watching this, we will have done an activity in class where you're looking at area models and finding the factored form that way. But the first step in all factoring is right here. Find factors of c, the constant, that have a sum of b, the coefficient of the linear term. So you're going to have situations where you're finding, so let's look at just one quick example. There we go, factors of c, so factors of 6 that have a sum of 5. Can you think of factors of 6 that have a sum of 5? 2 and 3. 2 plus 3 is 5, 2 times 3 is 6. To factor it, we know x squared. X squared only comes from x times x. And we know that the 6 is the 2 times the 3. And we know they're both positive. And if you go ahead and you FOIL that out in your mind, or if you write it out, you'll find it is indeed x squared plus 5x plus 6. So that's the basic idea of what we're doing here. We're going to talk about details. Look up here at the heading. In these examples, in these two examples we're going to do, b is greater than 0 and c is greater than 0. That's just like the example I did on the first page for you. So they point out that an easy way to organize all these factors is in a table. Obviously, that's not something we're going to write out forever, but you might want to do them to start. And remember that when you take notes, I do need to see that a concerted effort was put into your notes. So please write down at least the basic concepts here and the examples and some of the words so that you can go back and use them in class. Some of you know that your notes have been kind of mediocre and they're not very helpful in class. Let's get working on that. All right. X squared plus 8x plus 15 is the first one. So we're looking for factors of 15 that have a sum of 8. And the two pairs of factors of 15 are 1 and 15. They have a sum of 16, so that's not it. And 3 and 5, they have a sum of 8. And so you're just going to write it. X plus 3, x plus 5. And there you go. A check means just multiply it back out. Remember, this is your actual answer over here, though. All right, so how are we going to do this one down here? R squared plus 11r plus 24. Factors of 24 that have a sum of 11. Factors of 24. Now, it's important that you think about this logically. It doesn't make sense to start with 1 and 24, 2 and 12. 11 is kind of a smallish number. So the two factors are not going to be, 24 is not going to be one of them. 12 is not going to be one of them. So you want to think more in line with numbers that are going to be closer to adding up to 11. So how about we start with 4 and 6? 4 and 6 adds up to 10, not quite there. How about 3 and 8? That's it. 11. R plus 3. R plus 8. Getting the hang of it so far? All right, so when both b and c are positive, it's easy. You're looking for two numbers that have that product and that sum. Product of c, sum of b. Gets a little bit different as you go on with values that are negative, though. Let's look at a couple of those. Okay, when b is negative but c is positive, let's think about that. A positive product, negative sum. If two numbers multiply to give you a positive, they either have to be two positives, like 2 and 3, or two negatives, like -2 and -3. Both of those give you positive 6 for a product. Which one would give you a negative sum? The negative numbers would. So in all of these examples, where b is negative and c is positive, the two numbers you're finding are going to be negative. And so we just did that other problem. You can see here it's the same problem with an x and a -11 this time. And so if you go through systematically and think about the factors, It's -3 and -8. Let's try this one down here. Y squared minus 6y plus 8. Factors of 8 that add up to -6. Well, 8 only has a couple of pairs of factors. 1 and 8, 2 and 4. -2 and -4 do indeed add up to -6. So we've got y minus 2 and y minus 4. All right, look at the next one. Can you factor? Now, we know about composite and prime numbers. Composite numbers like 25 and 36 and 9, those are all composite numbers because they have more than 2 factors, right? Then there's prime numbers like 2 and 3 and 7 and 13. Prime numbers only have 2 factors, one in themselves. You can also have prime polynomials. And what you're going to do is you're going to say, all right, are there any factors of 2 that add up to -1? Well, the only factors of 2 are 1 and 2, or -1 and -2, respectively. And if you add those, you're going to get 3 here and -3 over here. So those factors do not exist. So we can't factor it. And that polynomial is what we would call prime, just like a prime number can be. All right, next example. Now we're looking at ones where C is less than 0. Now if C is less than 0, B can vacillate. B can either be vacillate, fluctuate, change. Sorry, used a big word, and I know I should probably define those when I do that. Okay, but B can change. B can either be positive or negative because it depends. If you're dealing with, in a circumstance like this, if you're dealing with a negative C, well, the only time you can get a negative C is if one of your 2 numbers is negative. But if you think about it, if you add them, -2 plus 3 is +1, and 2 plus -3 is -1. So the B could be positive or negative. It depends on the size of the factors that you find that multiply to give you your negative. If the positive one has a bigger absolute value, then the sum is positive. If the negative one has the bigger absolute value, then the sum is negative. So B will be back and forth, but C will be negative in these examples. So x squared plus 2x minus 15. So factors of -15 that add up to 2. And we've gone through again. We've done it systematically here in the book. So 1 and -15, -14. -1 and 15. Now look, again, it's pretty silly to think about these or to focus on these pairs of factors very long because we know that in this case, we have to have numbers that are pretty close together. I also want to point out, uh-oh, my music stopped. I also want to point out that we have a circumstance where you want to think more about the difference of your 2 numbers than the sum. Look, when we find the sum of -2 and 3, we're really subtracting 3 minus 2. 3 minus 2. And then we're making the answer have the absolute value of the bigger of the 2 integers. So instead of thinking about adding the 2 integers, you can also think about subtracting. If you think about positives, if you find positives and subtract them, you can think about it that way. So I could say, I'm looking for, I don't know why I can't get the music to start again. But anyway, I'm looking for 2 numbers that multiply to give me -15 and add to give me 2. So I could be thinking about 2 positives that multiply to give me 15 and subtract to give me 2. I could think about it that way and then decide which one is negative based on the fact that it's a positive 2. So the 5 would have to be positive and the 3 would have to be negative. So you try the next 2. I'm going to pause my video so I can try and get this music started again. You try the next 2. Think about what you're doing and I'll jump in and start them in a moment. Okay, so for some reason the Guitar Essentials iTunes radio station decided to stop working. So we're on to piano. Again, just trying to be relaxing here. All right, we need, hard to be relaxing when the air conditioning and the heat come on that way. Nearly jumped out of my skin. Okay, turn the music up a little bit since we now have that heat on. Factors in -36 that add up to 9. So again, I'm looking for factors of 36 that have a difference of 9. So that's a big difference, a big span. So again, I can go through mentally 1 and 36. Nope, subtract those and you get 35. 2 and 18. Nope, subtract those and you get 16, but I am getting closer. 3 and 12. Yep, that's it. Now, which one's the negative? Well, if we have a positive 9 for the sum, then the 12 has to be positive, and that's n, and the 3 has to be negative. Excellent. All right. Factors of negative 21 that add up to negative 4. Factors of negative 21 add up to negative 4. Well, there's not many factors of 21, so it's probably 3 and 7. So let's think about it. Which one would have to... 3 and 7. Try that again. Oh. Okay, hold on. I'm not going to be able to because I used the wrong tool. All right. 7 and 3. There we go. So which one is the negative? Negative 4, bigger absolute value is negative. C minus 7, C plus 3. Now let's just go back in, and I'll just use my pointer here. I haven't changed the pointer in a while. Let's change it to something else. Let's use the green arrow. Is that a superhero? The green arrow. Doesn't sound right. I don't know my superheroes. All right. So n times n squared. N times minus 3, minus 3n. 12 times n plus 12n. Minus 3 plus 12, positive 9. Positive 12 times negative 3, negative 36. Check. We've got that one right. Over here, c times c, c squared. C times plus 3, plus 3c. C times minus 7, minus 7c. Positive 3 and negative 7, negative 4. Negative 7 times 3, negative 21. Check. Onward. Okay, a little bit of mixed practice. And I'll turn down the ads on the iTunes Radio. Thanks a lot, iTunes Radio. So what I'll do is I'll go ahead and pause it in a moment and write this out. So you pause it, you try them, and see how you're doing. Okay, here they come. And there we have it. So let's run through these. Factors of 12 that add up to 7. Positive 3, positive 4. X plus 3, x plus 4, finished. Factors of positive 42 that add up to negative 13. Negative 6 and negative 7 multiply to give me 42. They add to give me negative 13. R minus 6, R minus 7. Factors of negative 40 that add up to 3. Positive 8, negative 5. P plus 8, P minus 5. Now this one's a little different. Notice that the 32 has a B squared on it. That just means that the constant in each binomial has a B on it. Because then when you multiply outer, you get plus 4AB, and then inner plus 8AB, and that's plus 12AB. And 8 times 4, 32, B times B, B squared. So there's not a lot of difference there. Okay, that's all we have to do is tack on that extra variable. Down here, we have factors of negative 28 that add up to negative 3. It's negative 7 and positive 4. All right, now let's talk about the difference of squares pattern. Won't take us but a second because these are pretty easy. Okay, so your difference of squares pattern, and the way they like to write it out is they like to use a and b or x and y. If for all real numbers, a and b, if a squared minus b squared is what you're given, you can factor that to a plus b, a minus b. So it's the square root of the first term, the square root of the second term, like in this case x and 8, one sum, one difference, finished. The square root of the first term, square root of the second term, so in this case 5x and 6, one sum, one difference. That's it. Okay, the difference of squares pattern when we multiplied it out is pretty easy. I think it's even easier to factor than it is to multiply it out. How about a squared minus 1? Factor square root of a squared, a. Square root of 1, 1. One sum, one difference. So I'm going to pause it, and you go ahead and you pause it, excuse me. Go ahead and try them, and I'm going to pause it and write it out. All right, coming right up. And there you go. So again, square root of the first, square root of the second, one sum, one difference. So these are not difficult. And let me make sure these are all nice and legible. Sometimes the plus signs don't quite appear all the way, I think, if you rush too much. Now, so you notice this was difference of squares, and then earlier it was x squared plus bx plus c trinomials, right? Well, it changes quite a bit when this constant isn't a 1. That's an ax squared plus bx plus c trinomial, and that's coming up in the next video. All right, so remember, factoring is only going to get easier for you if you practice, practice, practice. I'm sure we can find a ton of websites online to practice. Plus, you've got lots of problems in your book, and I will give you or provide digital copies of extra practice as well. All right? Thanks for watching. See you in class.